Hello everyone, today we're going to be going over the August 2024 Algebra 1 Regents exam. In this video we're going to be focusing on part 1, which are the first 24 multiple choice questions. A link to this test can be found in the description of this video alongside 3 other videos that are going to go over part 2, 3, and 4 of the same test. That being said, we're going to start off with number 1, which asks us what the correct factorization of x squared plus 4x minus 12 is. So whenever I want to factor something, I'm going to use FOIL. So what FOIL asks us to do, it asks us to find two numbers that multiply into this last number, negative 12, that also add up to this middle number, 4. So what are two numbers that multiply into negative 12 but add to positive 4? Those two numbers are negative 2 and positive 6. Negative 2 times 6 is negative 12, and negative 2 plus 6 is 4. So now that we know those two numbers, we need that to split this middle number into both of them. So now we have x squared minus 2x plus 6x minus 12. And now that I've split this 4x into negative 2x plus 6x, I can factor out each side. So on the left side, I'm going to factor out an x. So I'm going to be left with x minus 2. And on the right side, I'm going to factor out a 6, and I'm going to be left with x minus 2. So because I split that 4x into two numbers, I could pretty much split this whole polynomial into two halves and factor out each half. Now that I have two of the same values in the same parentheses, I'm just going to combine them into one parentheses. So I'm going to write x minus 2 and x minus 2 under one parentheses, and I'm going to write x and positive 6 in one parentheses, and I'm going to get x plus 6 times x minus 2, which is choice 4. Number 2 asks us which situation can be modeled by a linear function. So something that's linear is going to have a constant slope. It's not going to be changing. So if I were to graph it, it would just be a straight line either going up or down or across like that. Those are all linear functions. Choices 2, 3, and 4 are all going to be exponential growth or decay. Whenever you see the percent and an interest, which is being compounded, that is going to be an exponential growth. Over time, the amount of interest that the account earns is going to increase. So the amount that you're changing by is going to change, and the graph is going to look something like this. The same thing with number 3. This is an exponential growth. If the number of cells in an organism doubles every day, whenever you're doubling or you're multiplying or you're dividing, that is going to be non-linear. Why? Because let's say on the first day it has 2 cells. The second day is going to have 4, followed by 8, 16, 32, 64. The amount by which the numbers are increasing is changing. So again, it's going to have this exponential form. And number 4, it says the attendance of a professional sports team game decreases by 1.5% each year. Whenever you're dealing by percents and decrease, that is going to be decay. So this is going to exponentially decay every year. The only one that is linear is the printer problem, because the printer is always going to print 1 page every 3 seconds. The amount of pages that it prints is never going to change because the rate is the same, right? You're not doubling it. There's no percentage involved. It's going to be linear. Number 3 asks which expression is equivalent to 3 times x squared minus 2x plus 3 minus 4x squared plus 3x minus 1. So all they want you to do here is just to simplify this and to combine like terms. Now, from the way it's written, we can't simplify it just yet because some of these terms are locked up behind parentheses. So I'm going to have to break them out of these parentheses. The way I do that is by multiplying whatever's on the outside by whatever's on the inside. So in this case, in order for me to access this x squared minus 2x plus 3, I first need to multiply its inside by the outside 3. So 3 times x squared is 3x squared, 3 times negative 2x is negative 6x, and 3 times positive 3 is positive 9. And now that this is out of its parentheses, I can start combining like terms, but I need to do the same thing to this parentheses as well. So notice here that you have a minus sign. Don't fall for the trap. It's not just a minus sign, it's actually a minus 1. All right? It's minus 1 times whatever's inside of here, okay? The reason why it's invisible is because anything times 1 is itself, so the minus sign times 1 would still be the minus sign. But just know that in order to break something out of parentheses that has a minus sign in front of it, you multiply everything on the inside by the minus sign. So negative 1 times 4x squared is negative 4x squared, negative 1 times 3x is negative 3x, and negative 1 times 1 is positive 1. Now all that's left is to combine the like terms. So in this case, we're going to combine the terms that are alike or that have the same variable, if any, attached to them. So I'm going to combine 3x with negative 4x squared. Why? Because they both have x squared attached to them. So 3x squared minus 4x squared is going to be negative 1x squared, or just negative x squared. Then we have negative 6x minus 3x. So negative 6x minus 3x. Again, I'm combining them because they only have an x at the end. That's going to equal to negative 9x. And finally, positive 9 plus 1 is equal to 10. So this aligns with choice 4. 4 says, at Adeline's first birthday party, each guest brought $1 in coins for her piggy bank. Guests brought nickels, dimes, and quarters for a total of 28 bucks. There were twice as many dimes as nickels and 12 more quarters than nickels. Which equation could be used to determine the number of nickels, x, that her guests brought to the party? Right? So in this case, we have that nickels, or we know that nickels is equal to x. We know that there were twice as many dimes as nickels. So if I want to write the number of dimes that there were, it's going to be twice the number of nickels, or 2 times x. So just know that whenever you're dealing with twice, 3 times as many, 4 times as many, anything that has twice in it or times in it, you're going to multiply. And whenever you're dealt with something that's more or less, you're going to add. So in this case, the quarters, we know that there's 12 more quarters than nickels. So this is equal to 12 plus the number of nickels because it's more. All right, so this is the number of coins that each category has. But we know that when you add up all of these values, in addition to how much they're worth, they add up to $28, right? So the value of a coin is equal to the number of coins you have times its value, right? If I have 4 nickels, I don't have $4. I have 4 times however much a nickel is worth, which is 0.05 of a dollar, right? So not only to write this, all of these equations right here are adding up the value of the coins to be 28 bucks, right? But if I just add up x plus 2x plus 12 plus x, I won't get anywhere. I'll just get the total number of coins. In order for me to get their value, I need to multiply the number, or how many there are, by their respective values. So nickels are worth 0.05 cents. If I multiply them by x, I get the total value of the nickels. Then dimes are worth 0.1 of a dollar, or 10 cents. So 0.1 times 2x gives me the value of the nickels. And if I add that to 0.25, which is how many cents a quarter is equal to, times 12 plus x, I get the total value of quarters. And now, if I add all of these up, I should get $28, which aligns most closely with choice 3. Oh, actually, not be choice 3, it would be choice 2, okay? Moving on to number 5, it says a student creates a 4th degree trinomial with a leading coefficient of 2 and a constant value of 5. The degree of a trinomial, or a degree of a polynomial, or any sort of expression like these, is just the highest exponent. So in this case, a 4th degree trinomial is going to be a trinomial whose highest exponent is 4. The biggest exponent, or the biggest power you raise something to, is the value 4. So choice 3 and 4 are out because the biggest value for choice 3 is 2 and the biggest value of the exponent for choice 4 is 3, right? Only 1 and 2 have their biggest exponent, or the biggest power that they're being raised to, is to the power of 4, so they are 4th degree trinomials. And the correct answer is 1 because it has a constant value of 5. Both of these have a leading coefficient of 2, which is just the first number in the in the expression. But choice 2 has a constant value of 3, whilst choice 1 has a constant value of 5. If you're asking what the constant value is, it's the value without x at the end of it. Number 6 asks, when solving the equation 4x squared minus 16 is equal to 0, Laura wrote that 4x squared is equal to 16 as her first step. Which property justifies her first step? So what she did here was she started off with 4x squared minus 16 is equal to 0, and she added 16 on both sides to get 4x squared is equal to 16. So because we're adding, our property probably has to deal with addition, which is why choice 1 and 2 are out of the picture, because they deal with multiplication. Now all you need to know is that commutative property of addition, that's just saying that 3 plus 2 is the same thing as saying 2 plus 3, right? It's just moving around the addition. But this is only on one side of the equal sign. When I move around my plus sign, or my numbers, I'm moving them around only on one specific side of the equal sign. I'm not moving them across the equal sign. In order to move something across the equal sign, that's going to be the addition property of equality. So in this case, a 16 was added to both sides. If the 16 was added just to one side, that would be the commutative property of addition, right? You would just be rewriting the addition as negative 16 plus 4x squared. But because the 16 was moved across the equal sign, it has to be the addition property of equality. Number 7 asks us which expression results in an irrational number. The clear answer here is 4. An irrational number is going to be a number that cannot be expressed as a fraction, and someone who has a non-terminating plus non-repeating decimal plus can't be written as a fraction. So in this case, choice 2 is automatically out because you can do negative 2/3 plus 1/4 and your answer will be a fraction. That'll be negative 8 over 12 plus 3 over 12, which would be negative 5 over 12. Because this number is a fraction and can be expressed as a fraction or written as a fraction, it's rational. Choice 1, radical 3 times radical 3 is the same thing as saying radical 3 squared. Whenever you have a square root and a square, they cancel each other out, and the answer is 3. So 3 does not have a decimal, so its decimal terminates, right? It ends right here, 3.0. Same thing with number 3. Number 3, 5 times radical 81. Radical 81 is 9, so 5 times 9 is 45. 45 does not have a decimal. It terminates, okay? If you take the square root of a non-perfect square, like 3, it will always be irrational, okay? So if you're adding 1/3 to an irrational number, your product is going to be irrational, right? Your result is also going to be irrational. If you take the square root of 3, it's going to give you like 1.75 to so on and so forth, right? Its decimal never ends, and it's not repeating, right? It's not like it goes 1.7777 forever, that each number is different, okay? Number 8 asks us which equation has the same solution as x squared plus 6x minus 18 is equal to 0. So as you can see here, they have some value in parentheses, which kind of tells us that we need to factor. But if you look closely at this negative 18, I cannot factor it because there's no number that multiplies into negative 18 but adds into 6. It just doesn't exist. So because that number doesn't exist, we need to make up our own number. We need to find a number and replace this 18 with a number that does multiply into itself and add up to 6. So the way we do that is by completing the square. All right. So the first step we want to do is what I just said. We want to get rid of this 18 because this isn't helping us. This is making it impossible to factor. So we add 18 on both sides, and now we're left with x squared plus 6x is equal to 18. Now our next step is to do b over 2 squared to actually get the value of that mystery number, right? So if you don't know what your b is, all of these polynomials follow this format: ax squared plus bx plus c. All right, so a is the value in front of the x squared, b is the value in front of the x. So 6 is the value in front of the x, not the x squared. So we do 6 over 2 squared. That's going to be 3 squared, which is 9. So I'm actually going to have to add 9. But I don't just do it to one side, I do it to both sides. So if I add 9 to both sides, I'm left with x squared plus 6x plus 9 is equal to 27. So that's how I replace this 18. Originally I get rid of it, and then by getting rid of it, I just mean move it to the other side. And then to the side that I just got rid of it, or to the side that I just moved it from, I add that number that's going to work, or that 9. So now if I look at this, what's two numbers that multiply into 9 but add into 6? Well, it's going to be 3 and 3. 3 times 3 is 9, and 3 plus 3 is 6. So x squared plus 3x plus 3x plus 9 is equal to 27, right? I can now pretty much split this into the left and the right side. So now I can factor out an x and get x plus 3. I factor out a 3 and I get x plus 3. Do the same thing where I combine both of these parentheses into one, x plus 3, and I combine these two values into one parentheses, x plus 3. So I get that x plus 3 times x plus 3 is equal to 27, which is going to be choice 2. Now they wrote it as x plus 3 squared, which is legal, right? If you're multiplying the same value by itself, it's the same thing as just squaring it. All right, 3 times 3 is the same thing as 3 squared. So x plus 3 times x plus 3, same thing as saying x plus 3 squared. Number 9 says the heights in inches of 8 football players are given below, and it's asking us which box plot represents the data. So the way that a box plot works is that the leftmost line represents the smallest value in your data set, and the rightmost line represents the largest value in your data set, and the middle line, this line right here, represents the median or the middle value. So in this case, if I wanted to construct one of these lines, one of these charts by myself, my leftmost line has to land on the smallest value in my data. So the smallest value in my data is 69, so I know that this this whisker, right, or this line has to add up or line up to 69 on this number line. And the same thing with the largest value. My largest value here is 78, so I know that this whisker has to line up with 78 on my number line. And I know that my median, if I wanted to calculate it, well, I do need a calculator if I want to construct this graph, I would have to arrange my data from least to greatest. So 69, 70, 71, 72, sorry, there's actually two cases of 70. So it's 69, 70, 70, 71, 72, 74, 76, and 78. So this is my data from least to greatest. Now to find the median, you just cross out the same number of points on both sides. So cross out 2, cross out 2, cross out 1, cross out 1. And if you're ever left with two pieces of data in the middle, you can just add them and divide them by 2 to find your median. So 71 plus 72 divided by 2 is 71.5. So I know that my median is going to lie on the point 71.5. All right, that's the easiest way to construct a box and whisker plot. All you need to do, right? So which one of these choices matches up with what we just constructed? Well, choice 1 and 2 are wrong because this whisker, the leftmost whisker or the smallest value, lines up with 65. This says both of these choices are saying that 65 is my smallest value, but that value doesn't exist in my data set. The smallest value is actually 69. All right, so now I'm left with choice 3 and 4. 3 and 4 both align at 69 and 78, so I know that the whiskers are correct, but what about the median? And that's why I had to calculate the median, because the median for both of these are different. This one, if I were to extend this line downwards, this whisker lies between 71 and 72, which is 71.5. This whisker lies between 72 and 73, which would be 72.5. So I calculated my median to be 71.5, which is why choice 3 has to be the correct answer. Number 10 says that a bookstore owner recorded the number of books and the profit made selling books. What is the average rate of change in dollars per book between 100 and 350 books sold? So the average rate of change is the change in Y over a interval. The actual equation for that is f of b minus f of a over b minus a, or over the interval b a. So starting from A and ending from B. So in this case, we know that we're looking at it over the interval 100 to 350, right? So the average rate of change is just on average, how much did our Y change over this interval, right? It's just a fancy way of asking for the slope over two specific points, right? So in this case, the beginning of my interval is 100. So the start of my interval is 100. And we're going all the way up to 350. So I'm going to say 100 is my A and 350 is my B. So I'm going to do 350 minus 100 over f of B. So the Y value when my book sold, or the Y value at the start of my interval, right? Which is going to be $425 minus the Y value at the other part of my interval, which is 100, which would be $50. Right? So all you need to do is subtract the interval, right? Subtract the finish minus the start of your interval. So your interval, you're ranging from 350 to 100 books. So you do 350 minus 100. On top of that, you write the Y values at that end of the interval. So the end of the interval is 350. 350 books sold corresponds to $425 in profit, and 100 books sold corresponds to $50 in profit. So if you plug this into your calculator, you get $1.50. Number 11 says, if f of x is equal to x squared, then which function represents a shift of the graph f of x 4 units to the right and 3 units down? So in this case, you just need to remember that whenever you're shifting up and down, you're going to add 4 to the end of f of x, and whenever you're shifting left and right, you're going to add the number to x. So left plus right, left or right, you're going to be adding inside of the parentheses. So you're going to add or subtract 2x. And if you're going up or down, you just attach it to the end of f of x. You're going to add or subtract the value to the end of f of x, okay? Just know that if you're shifting it to the right, you're going to be subtracting from x. And if you're going to the left, you're going to be adding to f of x. If you're going up, this is more intuitive. If you're going up, you're going to add. If you're going down, you're going to subtract. So I have f of x. If I want to shift it 4 units to the right, I'm going to have to subtract 4 units from f of x. So I'm going to do f of x minus 4, and then I'm going to add I'm going to subtract 3 from the parentheses, right? 3 outside of everything, outside of the f of x, to shift it down. So obviously, this doesn't align with any of our answer choices because I forgot to plug in I forgot to plug in x minus 4 into x, right? So all you need to do is plug in x minus 4 into f of x. So I'm saying that x is equal to x minus 4, and I'm plugging it in to x squared. So now it's x minus 4 squared minus 3, which is going to be choice 3. All right? So all you do is you subtract from the x if you're going left to right. You subtract from the whole function if you're going up and down. Number 12 says the amount of money a plumber charges is represented by the function p of h is equal to 45 plus 90. The best interpretation of the y-intercept of the function is that the plumber charges what? The y-intercept is going to be the constant, the flat fee, or the initial cost. The y-intercept never changes. Its value is always the same. So if I have the function p of h is equal to 45 plus 90h, which one of these values is going to change over the span of the example? This value is going to change because this value is equal to 90 if you work 1 hour, but if you work 2 hours, this is going to be 90 times 2, which is 180. If you work 3 hours, it's going to be equal to $270, right? Because you're multiplying it. So the value with the variable is called the slope. The value without the variable is called the y-intercept. So in this case, my y-intercept is 45. So I'm going to eliminate choices 3 and 4 because they identify 90 as the y-intercept, which is wrong. Now, the y-intercept is always going to be constant, so which is why it has to be 1. Choice 2, $45 per hour. Whenever you see per, that means that that's the slope. This 45 is not our slope. It's our y-intercept. So choice 2 is saying that it's our slope, which is why choice 2 is invalid, okay? If I'm earning $45 per hour, this value is going to change based on the number of hours I work. If it's just $45 to come inside of the house, then that value is never going to change. It doesn't matter if you're going to work for 3 hours, 4 hours, 7 hours, it's always going to cost you the same amount, or he's going to charge you the same amount just to enter the home. Number 13 asks us to solve for m, or what the solution to 2m minus 4 is less than or equal to 3 times 2m plus 4 is equal to. So again, over here, it's the same deal. We're going to have to combine m, or combine like terms. One of them is stuck in a parenthesis, so we're going to have to distribute whatever's on the outside. So 2m minus 4 is less than or equal to 3 times 2m, which is 6m, and 3 times 4, which is positive 12. Now I just need to combine like terms by moving my variables around. So I'm going to subtract both sides by 6m. 2m minus 6m is equal to negative 4m, and negative 4m minus 4 is less than or equal to positive 12. Now I'm going to add 4 to both sides, and I'm going to have negative 4m is less than or equal to positive 16. Now I want to get m on my own, right? Or on its own. So I'm going to divide both sides by negative 4. And when I do this, this is a very, very important detail. You need to change your sign, right? Your sign flips. All right? So this negative 4 divided by negative 4 is just going to give me m, which is what I want. But because I divided by a negative number, this sign changes direction. So it was open in the right direction, now it has to be open in the left direction. So I'm going to be left with m is greater than or equal to negative 4, which is going to be choice 4. Number 14 says a survey of students at the West High School was taken to determine the theme for the prom. The results are summarized in the table. Approximately what percentage of students who chose the Broadway theme were girl? So whenever you see of the students or of the blank, it means out of those students, right? So whenever I want to find a percentage, I know I'm going to be dealing with part over whole. That's just the equation, part over whole. And of the blank tells you what my whole is, right? Of the blank is the whole. So of the students who chose the Broadway theme, that means that I'm only looking at the students who did choose the Broadway theme. This box right here is representing the people who chose the Broadway theme. I'm selecting, or I'm looking out of them, right? This is going to be my whole because of the blank gives you your whole. So you can cross out the rest of this table. You will never ever use the rest of this table for this problem because they told you to only look of the Broadway people, out of the Broadway people. So I know that my whole is going to be 68 plus 79 because 68 girls chose it, 79 boys chose it. So the total amount of people who chose it is going to be 68 plus 79. And we're going to divide this by my part. I want to see what percentage of students were girls. So out of this whole, out of everyone who chose Broadway, how many were girls? Well, 68 of them were girls, all right? So all you need to do is just plug this inside of your calculator, and you're going to get that this is equal to 46%, right? You're going to get 0.46. If you multiply that by 100, you get about 46% as the correct answer. Number 15 says, or asks us, the sum of 2 radical 45 and 2 radical 6. So whenever you want to add radicals, you want to make sure that whatever number is under the radical is the same. So 2 radical a plus 2 radical a is equal to 2 plus 2 times radical a, right? You're just going to add the numbers on the outside, and the number on the inside stays the same. But you can only do this when the two radicals are the same, right? When they're both in terms of a. In this case, 2 rad 54 is out of 54, and 2 rad 6 is out of 6, so I can't add them right now. I need to convert both of these into the same base, right? So in order to do this, I need to just remember a very simple rule, right? So whenever 2 rad 45 is the same thing as saying 2 times radical 54. And another cool thing is that if you take radical a times radical b, that's going to equal to radical a times b, right? It's over the same thing. So essentially what I'm saying is we can split this up into a base that's the same as 6, right? So what are some numbers that 54 splits up into? Well, 54 splits up into 9 times 6, right? And I can use this rule up here. I can say that 2 rad 54 is the same thing as saying 2 times radical 9 times radical 6. Remember, radical a times radical b is equal to radical a times b. So that's the same thing as saying radical a, which let's say is 9, times radical b, which let's say is 6, 9 times 6, which is 54, right? So it's the same thing. We just rewrote it and we split it up. But remember that 9 is a perfect square. The square root of 9 is 3. So we're actually left with 2 times 3 times radical 6, which is 6 radical 6. Now I can drop down this plus 2 radical 6, and now we can combine them and get 8 radical 6 as my answer, which is choice 4. 16 says the function f of x is equal to x squared minus 5x minus 4, and g of x is equal to x plus 2 are graphed on the same set of axes. What are the solutions to f of x is equal to g of x? So all we need to do is just set these equations equal to one another. It's saying that g of x is equal to x plus 2, f of x is equal to x minus 5 minus 45. So whenever I see f of x, I can plug this in for f of x, and whenever I see g of x, I can plug this in for g of x. So they already gave me my equation. F of x, which is x squared minus 5x minus 14, is equal to g of x, which is x plus 2. Now all I need to do is get my variables on one side. So I'm going to subtract x on both sides. I'm going to get that x squared minus 6x minus 16 is equal to 0, right? So I subtracted 2 on both sides as well. Now I'm going to be looking for a number that multiplies into, two numbers that multiply into 16, negative 16, and add up into negative 6. Those two numbers are going to be positive 2 and negative 8, right? Positive 2 times negative 8 is equal to negative 16. So I can split this negative 6x into x squared plus 2x minus 8x minus 16. And now I can factor out both sides. I can factor out an x from this side and get x plus 2. Factor out a negative 8 from this side, get x plus 2. Combine these two parentheses into x plus 2 and x minus 8. And remember that all of this is all equal to 0. So now the solutions to this are going to be the values that make this true. I essentially combined both of these together and set them equal to 0. Now I need to see, well, what values actually make this true. The values that do make it true are always going to be called our solution. So in this case, what two values make it true? Well, any value that makes any one of these parentheses equal to 0 will make it true, right? So why? Because anything times 0 is equal to 0. So x plus what makes it equal to 0? Well, x plus negative 2, right? If x is negative 2 plus 2 is equal to 0. So the first solution is going to be negative 2. The second solution is going to be this one that makes this parentheses equal to 0. So x minus what number makes it equal to 0? Well, if x is 8, 8 minus 8 is equal to 0. So the second solution is 8, which is why the answer is 2, right? Yeah, and this makes sense, right? Because if I were to plug in 8 for this, I would have 8 minus 8 times x plus 2. I have 0 times x plus 2, which equal to 0, and the same thing if I plugged in negative 2. So that's how we find the solutions between these two. We set them equal to each other, then we combine like terms and make one side equal to 0, and we solve for the values that make that being equal to 0 true. Number 17 says if x is equal to 4a squared minus a plus 3 and y is equal to a minus 5, which polynomial is equivalent to the product of x and y? So the product is what's going to happen when you multiply x and y together. So all I need to do is just multiply x and y together. I know that x is equal to this and y is equal to that, so I can just plug those values in for x and y. So I'm going to have a minus 5 in parentheses times 4a squared minus a plus 3. The parentheses are very necessary whenever you're multiplying polynomials. You need to have the parentheses. So now all I need to do is the same thing as if there was just one number outside the parentheses. I multiply anything inside of this parentheses by anything inside of here. So the best way to not get lost is just to draw an arrow. So I'm going to draw an arrow from each one of these terms into each one of these terms, right? And the arrow means to multiply. So a times 4a squared is 4a to the power of 3. A times negative a is negative a squared. A times positive 3 is positive 3a. Negative 5 times 4a squared is negative 20a squared. Negative 5 times negative a is positive 5a. And negative 5 times positive 3 is negative 15. So now I just need to combine my like terms. I don't have anything that has a cubed attached to it, or a to the power of 3 attached to it, so I can't combine 4a cubed. But I can combine negative a squared with negative 20a squared, which would give me 4a cubed minus 21a squared. And I can combine this 3a with this 5a to get positive 8a, and this negative 15 I can't combine with anything, so I attach it to the end. That's going to give me choice 4. Number 18 asks us, what is the equation of a line that passes through the point 3, 7 and has a slope of 2? Whenever you're given a slope plus a point, you're going to use point slope form, which just says y minus the y value is equal to m, or the slope, times x minus the x value of that point, right? So we have y minus the y value of the point, which is 7, is equal to the slope, which they told me was 2, times x minus the x value, which was 3. So which one of these choices reflects that? That's going to be choice 1. Number 19 says that a geometric sequence with a common ratio of negative 3 is what? So a geometric sequence is going to be a sequence of numbers who are related by multiplication. So for example, 2, 4, 6, 8, and 16. This is a geometric sequence because to get to the next number, they have the same rule of multiplication. You just multiply it by 2, right? Every number in this sequence, to find the next one, you multiply the previous one by 2. That's what makes it a geometric sequence. And what makes it a sequence is that to get to the next number, you follow the same rule all the time. So in this case, that rule is called the common ratio. That's the number that you multiply by. So in this case, the common ratio is negative 3. To get to the next number, you have to multiply by negative 3. The only sequence that follows this rule is going to be choice 4, right? In this case, 4 times negative 3 is equal to negative 12. Negative 12 times negative 3 is equal to 36. And 36 times negative 3 is equal to negative 108. Don't fall for the trap of choice 3. Choice 3 had negative 2, negative 6, negative 18, negative 54. The rule here is actually to multiply by positive 3, not negative 3. Remember, if you're multiplying it by negative 3, negative times negative is positive, positive times negative is negative, negative times negative is positive, right? So whenever your common ratio is negative, you're going to have an alternating plus minus plus minus. Here they're all minus, which means you're multiplying by a positive number. So a negative common ratio is going to have a alternating sign within it, okay? So that's just what you need to remember about common ratios. Number 20 says that when the equation 6 minus ax is equal to ax minus 2, when that's solved for x in terms of a, the result is what? So whenever you see blank in terms of blank, that first term is what you're going to solve for. So I'm going to take 6 minus ax is equal to ax minus 2, and I want to solve for x. Don't worry about the in terms of a. It's literally just asking you to solve for x, okay? So let's solve for x. Let's add ax on both sides, and we'll get 6 is equal to 2ax minus 2. Remember that ax plus ax is not equal to 2a 2x, right? All of ax is just one term. So you're adding that one term to itself 2 times, which is the same thing as saying 2 times ax, right? So now I want to add 2 on both sides. I get that 8 is equal to 2 times a times x. Now I want x. I want to solve for x. So I'm going to divide both sides by 2a. And I'm going to be left with 8 over 2a is equal to x. Perfect, right? Now which one of these choices matches that? It's going to be choice 2. How? Because all they did was they simplified 8 over 2a by dividing the top and the bottom by 2. They simplified the denominator into 4 over a, and that's equal to x. Number 21 asks, which functions have zeros of -1, 3, and -4? AKA, when I plug in -1, 3, and -4 into these equations, which one of them is equal to 0 at all of these points? The correct answer for that is going to be choice 3. If I plug in -1, I'm going to have -1 plus 1 is equal to 0, and anything times 0 is equal to 0. So that makes this whole function 0. The same thing with 3. For this function, if I plug in 3, I'll get 3 minus 3 in this parentheses, which makes it equal to 0. Anything times 0 is equal to 0, so the whole thing is equal to 0. And the same thing with this last parentheses right here. -4 plus 4 is equal to 0. Anything times 0 is equal to 0, right? So the zeros of a function are the values that make that whole function equal to 0 at that point when you plug them in. 22 asks us to simplify 5 or rewrite 5 to the power of a plus 2b, right? So for this, you need to know two rules. The first rule is that a to the power of b times a to the power of c is equal to a to the power of b plus c. In other words, 5 squared times 5 squared is equal to 5 to the power of 4, or 5 to the power of 2 plus 2, right? Whenever you have the same base, all you can do is you can add the exponent together, which makes sense, right? Let's say you have 5 squared times 5 squared. If I were to rewrite this the long way, 5 times 5 times 5 times 5, right? I split these 5 squared, into what they actually represent. That's 5 times 5 times 5 times 5. How many 5s am I multiplying by themselves? I'm multiplying 4 5s by themselves, right? Which is the same thing as 2 plus 2. And then the second rule you need to know here is that a to the power of b raised to the power of c is equal to a to the power of b times c. Okay, so 5a times 5 to the power of 2b is the same thing as saying 5 to the power of a plus 2b. So essentially, we got this 2b out of the exponent and onto another 5. But you might be asking, well, what does this match? This actually doesn't match anything. And that's because we need to take into account our second rule. Remember that a to the power of b to the power of c is the same thing as saying a to the power of b times c. So 5 squared raised to the power of b is the same thing as saying 5 to the power of 2 times b. So we can rewrite this as 5 squared to the power of b. But 5 squared is 5 times 5, and we can simplify that into 25, which turns into 5a times 25 to the power of b, which is choice 2. Number 23 says that in an arithmetic sequence, the first term is 4 and the third term is -2. What is the common difference? So an arithmetic sequence is just going to deal with adding or subtraction. So it's the same thing as a geometric sequence. All of the numbers are going to follow the same rule, but instead of that rule being instead of that rule being multiplication, that rule is addition or subtraction. Okay? So it's saying that the first term is 4. So if I want to write down the positions, I know that my first position is 4, and my third position, or my third term, is -2. So how many times did I need to apply my rule in order to get from 4 to -2? Well, I applied my rule once, and I applied my rule twice, right? So I don't know how much I subtracted by, but I know that it happened 2 times, right? So 4 minus, because I know I'm subtracting, right? Because I'm going down, right? And the common difference never changes. It's always the same. So I'm always going to be subtracting. And the common difference is always the same, so I subtracted by the same amount. Let's say that this is x and this is x, right? I subtracted 4 by x twice. So I have 4 minus 2x is equal to -2. Now I can solve for x. I'm going to add 2 on both sides. I'll get that 6 minus 2x is equal to 0. I'll add 2x on both sides. I'll get that 6 is equal to 2x and that x is equal to 3. So actually, I subtracted by 3 each one of these times to get my answer, which makes sense, right? What's 4 minus 3? 4 minus 3 is positive 1. What's 1 minus 3? It's -2, right? So you subtracted by 3 both times. Last question in the section. It says that Joe is ordering water for his swimming pool. He determines the volume of the pool to be 3,240 cubic feet, and there are approximately 7.5 gallons of water in 1 cubic foot. The truckload holds 6,000 gallons of water. Which expression would allow Joe to correctly calculate the number of truckloads he needs to fill the pool? Right, so you're converting the original volume of the pool of 3,240 cubic feet into truckloads. So which one of these does that correctly? Well, I want to have truckloads as my final value, right? I want to have truckloads per pool. So which one of these correctly does that? You don't even need to do any math. You just need to look at the units here. Which one of these problems leaves me with the proper units? Well, let's look at it. Choice 1, you're multiplying feet cubed by feet cubed. So they never cancel out. So my units here are going to be feet to the power of 6 times gallons divided by 7.5. Well, the gallons are going to cancel out. But then you're going to be left with pool times truckload, which doesn't make sense, right? I want truckloads over pool. I don't want feet cubed over pool times truckload. So here they did their multiplication wrong because the units didn't cancel out. The same thing could be said with choice 2. Feet cubed plus feet cubed is going to leave us with feet to the power of 6 times truckload over pool times gallons squared. So those units are all messed up as well. So now I'm left with choice 3 or 4. Choice 3, the feet cancel out perfectly, but my gallons don't. So my units are going to be gallon squared over pool times truckload, which doesn't make sense, which leaves choice 4 as the correct answer. Notice here, they have feet cubed in the top, feet cubed in the bottom, so those two cancel out. They have gallons in the top, gallons in the bottom, and the only units that survive are truckloads per pool, which is what I wanted to find in the first place. So another cool trick with this is whenever you have the same number in the numerator and the denominator that are across from one another, you can just cancel them out and turn them into 1, or pretend like they don't exist there. So that's what we're doing here with the units. The same thing can be done with units. If you have feet in the numerator and feet in the denominator, you can cancel them out and turn them just into 1. So you're getting rid of the letters. All right. So that's all 24 questions in this section gone over in one video. Just note that if you want to continue going over this exam, those parts are in the description of this video as well. If you have any questions to what we did or any of the questions here, please let me know in the comments down below. I hope you guys learned something. I hope you have a nice day.